home. You can get out of here. All right, sweet. As long as you are good, as long as you have got that project turned in from yesterday, then you can go. Okay, but if you haven't, come on through, Xander. You're good. You can be on the show. If you have turned the project in on Canvas and you're good to go, you fill out that. There's a question at the bottom of that last page, so don't miss that. Just a quick final conclusion worth 5 points. Then you're good. Okay. Tomorrow, quick reflection on Canvas and chapter 2 or unit 2 is done. Okay. But if you did not get that final project done, then let's do it right now. Okay. Same thing here. Let's take out that project from our drops, and let's start doing some comparisons. Right. We looked at the whole thing. Mean the standard deviation is awesome. Good to go. Now let's put it all together. Now, I think, and correct me if I'm wrong, on Tuesday, we got this whole thing filled out, right? That we got the big bell curve filled out. Did we do the answers at the bottom? The 68, 95, 99.7? Some of us maybe did, some of us didn't. But what's nice about having this thing filled out right now is that section right there. Now, I'm just going to make these numbers up so it's easier for me to write. Let's say it was... whatever. Let's say I was at like 15 and my standard deviation was 3, 18, 21, 24, 12, 9, 6. Let's say those were my numbers. Now, it's not perfectly normal because realistically, like my bell curve had like negative numbers and numbers bigger than 30. That's not possible. So we know our data isn't perfectly normal, and that's okay. We can talk about it like it is. And what the 68, 95, 99.7 rule told us is that just go like above or below 1 standard deviation from your mean, 68% of the data is going to fall in that spot. And so when I get down to question 3A, for me, if my numbers look like this, 68% fall between what two measurements? For me, 1 to the left and 1 to the right, they're going to fall between 12 and 18. For you, you've got different numbers. But just pick the numbers that are just 1 standard deviation above and below. You got decimals and stuff, it's cool, so write down everything. So the numbers that are circled in red, for me, right, 1 below, 1 above, 68% are going to fall in those. So like 2/3 of my numbers kind of fell within that range. And you might find that that's pretty true for you. Whatever those numbers are, you're going to see, yeah, I was kind of between like 10 and 18 most of the time. Okay, next one was 95. That's just plus or minus 2. So I'll write it up here so I don't have to scroll. But for part B, I would say these numbers. Between 9 and 21. For you, it's going to be a little bit, 1 less and then like 2 less. I got you.
You're my math coach. You're my math coach.
Did you call me coach?
Yeah.
You are in wrestling mode, aren't you?
Oh, yeah. Also, figure out here, he's somebody come over to the building distance.
Nice. Sounds awesome. All right, and then C was 99.7. That's just the last one at the left, and the last one at the top. So for me, that's 6 of 10. 99.7 of my data is going to fall between those two, if those are mine. Now, realistically, my numbers are like negative 0.5 for the far left. Of course, I don't have any numbers down there. I didn't catch it before it dropped. But now we're done. That's easy. That page is good. Okay. In order to do the next page, we have a little bit of prep work to do. Okay. So when you look at your data, right, you got your big bell curve here. Okay. The numbers that you have along the bottom, what you're going to have to do to answer these questions is transfer those same exact numbers over to both of these bell curves. So whatever your numbers were down here on the big one. So Sid's got the right idea. Like open up your page like this. So you see both of them at the same time, put them flat. These two smaller bell curves on this next page are the same as the big one. What's up, Mickey? So we just finished part 3. We finished the big, nice bell curve for part 3.
Yeah, no, I'm on part 5.
So we're not even on part 5 yet, collectively. For us, we're doing part 4 right now, but we need to copy that. Now, you don't need the percentages. We just need the numbers along the bottom for part 4. Because now we're going to do the z-scores that go with it. And once you do that, then we'll work on it together. So I'm gonna scroll. Well, actually, I'm gonna look and then you take a peek at this one.
What do you already have there?
Sweet. So you're ahead of the game, so that's cool. Okay, and once you have these 2 bell curves filled out, so I'm going to stick with the same one. I'll just start with the top one. So mine was 6, 9, 12, 15, 18, 21, 24. Now what we want to do is we want to pick on a couple of our drops. And we want to see, really, how good was my best one? When I compare myself to myself, and I look at my best drop, how good was it really? Like, does it really stand out head and shoulders above the rest? Or is it just like a little bit better than my second one? That kind of thing, okay? And so what you're going to do is you're actually going to turn back to your actual data, and you're going to figure out where your best drop was. In other words, which one had the smallest number? Like, maybe your best drop was 4. And it happened on drop 16. It was the 16th drop. And for, like, I'm just making this up. But like I said, my 16th drop was my best one. And I caught it at 4 centimeters. Find your absolute best. So the centimeters is your smallest number. A drop is just whichever one it was. Okay. And once you find your best one, and you might have a couple duplicates. If you had like the same number twice, just pick one of them. Doesn't matter. All right, step 1, use the mean and standard deviation to fill out. Cool, done. Step 2, draw a vertical line on this graph above to estimate that number right there. Oh, for me, 4 is like over here. It's going to be on the left-hand side because it's one of your smallest numbers. It is absolutely your smallest number. And so it's going to be somewhere on the left edge, right? But put a line wherever you think that's going to be. Now, remember, like for me, my average, my mean was 15, and my standard deviation was 3. Okay? This number up here, that's the value. That's the number that I'm like kind of picking on and really trying to figure out, okay, if that's my best, how good is my best really compared to everything else? And that's what z-scores do, right? The smaller or the bigger kind of gives us a good sense of where we're at. And so that's what I'm going to do is I'm going to calculate the z-score for this. The value, so for me, my actual drop, right? The centimeters, not the drop number, that was just kind of arbitrary, but the 4 minus the average, minus your mean, so minus 15, all over. For me, those are mine. Use yours. So whatever your number is next to centimeters, put that first. Subtract your average, which you already have written down because that's right here. Right? There's your average. You might have to peek back to see what your standard deviation was because you've got decimals and stuff. And see what you get. Let the calculator do the work. So for me, I'm at negative 11 over 3, which is approximately, we're going to go 2 decimal places. That for me is approximately 3.6. That's my z-score. That's how good it was. The smaller that number, the better you did on your best. But if that was more like a negative 2 point something, then your best is actually a little bit closer to a lot of those numbers down there at the bottom. And that's not it's not bad versus good. It's just kind of like picking on a certain spot and comparing where you're at. Value minus mean over the standard deviation. That's your z-score. On the next page, we're going to use these z-scores in table A, and I'll pull up table A here in a second. But let's do it again for your slowest one, down there at the bottom. Go back, take a peek, figure out what your slowest reaction time was. So your biggest number, your biggest centimeter. 27, 30, 24, whatever it was. So let's say my first one was terrible. Let's say my absolute worst one was my first one and I got like 28. Do the exact same thing, but drop that vertical line, drop that arrow if you want to draw the arrow, write it wherever 28 would be. Calculate your z-score for that. Same way, just the only number that's going to change, my 4 becomes a 28, but my mean's still the same. Damn, almost died. Standard deviation is the same. Take 2 decimal places. Again, if you have to like round that second decimal place up, you're looking at that third number, right? The third decimal. If it's a 5 or above, give it a shove, bump it up. So, because I got 3.666666, right? So I got 3.66 or 3.67. Well, I had to look at that next number. It was a 6, 5 or above. So I bumped up the 6%. And remember, if this was actually normal, you don't have to write this down, but numbers to the left of this only represent 0.15% of the whole data. And so I'm better than like 1%. Like that's how good that number for me really was. Because for us, goodness is small, right? Badness is big. Sometimes those are switched, right? Basketball points per game, I want it to be big, but in golf, I want my average score to be low, right? So it kind of depends on what you're looking at. But when we compare things in statistics, a lot of it comes down to this idea that, and like we did a question on it, we didn't spend a ton of time, but there was a question about baseball batting average. You look at every Major League Baseball player from last year, you look at batting averages, they're going to be normal. And when you look at somebody that wins the batting title, how much better are they really? Look at their z-score. And then jump into table A and see what percentage falls less than, well, if they're the best, that's going to be 100%, everybody's less than that. But how good are they really? Is their z-score 3 or is it like 7? And when, I know we talked about it again briefly, it was something else, but when we first did stuff in the Unit 1 final project, I showed you, I think, or was it leading up to this? I forget, but Miss Sigmund did a great white sharks project for herself as an example, and compared like the size of the biggest 30 great white sharks that ever been found, and like laid them out and did a whole normal distribution, and kind of picked like the middle one, like some of the smaller one. He talked about like, oh, is a 12-foot great white like really big, or is that really small? Like, where's that at? The biggest great white shark is a shark called Megalodon. You ever heard that? Megalodon's z-score was like 15. Like, this curve goes like this. Dude was like out here. Like, so huge compared to everybody else. And it really tells that story. Like, oh, Megalodon was 60 feet or whatever it is. Like, okay, that's obviously really big, but how big is that? No. And that's what statistics can do. All right, turn to the next page if you're ready. Now, if I did your slowest and your fastest again, and we did the table A, it would just be 0% for your fastest and 100% for your slowest. So that wouldn't make any sense. So I decided to pick on your first drop and your last drop. Okay, so go back to your data and write down what your first drop was. Let's say my first drop was 7. Again, I still have the same mean. Right? My mean is 15. I still have the same standard deviation if I'm doing this. And what I did to save us a little bit of time is instead of having you write out the bell curve again, I just wrote down like what the z-score spots would be. Right? 0, 1, 2, and 3, or -1, -2, -3. And we're going to use table A here in a second, but I think it would make sense for us to get the z-scores done for both of these first. Like, get your z-score for your first drop. Let's say my last drop was 16. Get your z-score for your first one. So for me, 7 minus 15 over 3. -8 over 3, so that's about -2.67. Draw that line. Oh no, hold on, don't draw the line. We want to shade it. I'm actually going to pick up something here. Hold on. Let me pick a better number so you can see what I'm talking about. Let's change this up. I'm going to pick something a little bit more towards the middle. Just let's pretend it all worked out. Let's say I was at 14, -1, -0. Because instead of just dropping that line down and saying, oh, here's your z-score, what we're going to do is we are going to shade underneath the bell curve to the left. So -3.3. So I'm just going to go from like the top of the bell curve down, and then I'm going to shade that space. I'm going to kind of color in the area underneath the bell curve. And we're going to figure out what percent of my drops fall in that space. In other words, how many of my drops were better than my first one, right? Because goodness for us is small, right? Sometimes goodness is bigger. Goodness for us, I want small numbers. So whatever your first drop was, write that down, find the z-score for it. And then you can just, we don't have to worry because we've got that really nice kind of layout for the z-score. Because sometimes bell curves are drawn with, here are my mean and my standard deviation. Sometimes we just put the z-scores along the bottom. It's really the z-score that I care about. Drop that perpendicular straight down from the curve and then shade it over. Now you might have a super tiny section, you might have a super big section, it might be right down the middle, whatever it is. And again, let's do the same thing for your 30th drop before we jump into table A, so I'm not going back and forth, back and forth, back and forth. Okay? So I'm going to do that. I'm going to slide this down. It should line up real nice. Boom. Money. Okay, I'm just going to switch my numbers because maybe, let's say, my last drop. Let's say I was starting to get real tired. My last drop was like a 27. Struggling a little bit. Z-score of something for a drop like 27. Let's see. Well, maybe that's too big. That's a little too big. I want to pick numbers that kind of fall nicely somewhere. Let's pick 1. I'm back. Computer died. Hopefully it didn't die too long ago. But we're good. Once you get that final conclusion done at the bottom, I just kind of talking about, did I get better? Did I get worse? Did I generally stay the same as I went? That's kind of up to what your numbers look like. If you have a big standard deviation, then you were not consistent. You can say stuff like that. If your standard deviation was small, like 1 or 2 compared to 4 or 5, then you were more consistent, and you can make conclusions like that. You can talk about your best drop being way better than all the others, your worst drop being way less, your first drop, kind of where that fell. Like I was actually pretty good with my first one because only 15% of my data was better than that, right? That's what that table A percentage is. How many, that step 3 on that back page, right? Find the probability of using table A. It's all about saying how many of my drops were better than this one. So if you get a big number for step 3 on part 5 for each of your first drop or your 30th drop or both, if you get a big probability because your z-score is huge, that means that was one of your worst drops, right? Because you're way at the end, and so much of your data is better because we want small numbers in this case. Okay, but once you do that, and it can be quick, it's only worth 5 points. So quick sentence or 2 for your final conclusion. Put it on Canvas. Unit 2, final project. Take some pictures. You don't have to fill out that back page, the physical that last page with the standard deviation by hand, unless you did it already and you wanted to. That's cool. Put it on Canvas and you're done, and you can get out of here. Okay. Tomorrow's week 9 reflection is an important one. Okay, so I really, really, really need you to fill that out tomorrow, not just for attendance, but we want to do something next week. Practical knowledge that you can take with you after high school. Taxes, credit, loans, whatever. Anything related to numbers that you think is going to be helpful for you. Here's how I fill out my W-2 when I get my first job. Do I choose 0 withholding? Do I choose 1? What's a dependent? How do I figure out how much taxes I'm going to owe? How do I save money? We can talk investments. There's so many different things that we can do, but we have a week to do it. Okay, Monday, Tuesday, Wednesday, Thursday, and I want to hear from you as to what you think is most important. What do you really want to hear from me that has nothing to do with the stuff that we've been doing? Okay, because now you know a lot of statistics, and that's basically your introduction to statistics. Okay. After this is all probability. Of course, they're intertwined. Probabilities is percentages and stuff, but z-scores and all that kind of stuff we're done with for the time being. Okay, so we have a lot of flexibility next week, and I want to do what you want to do. I want to hear from you. I want to give you some knowledge that's actually useful. So tell me what it is that you want to actually look at, and we'll do that. Okay, so fill out the reflection tomorrow by 3 o'clock, so I can put it in for attendance. Or just at all, so that we can, Sigmund and I can figure out what next week looks like. Okay, then we'll go on spring break and we'll relax. We won't have anything to do. When we get back, we'll start talking probability for our last 6 weeks. I think we have after spring break, right? And then we have senior finals, and then you guys are done. Sweet, crazy. All right, I'm gonna stop recording because we're good. You guys can head out when you're done. Hit me up if you have any questions, of course, and fill out that reflection tomorrow. And I will see you on Monday. Peace.